Welcome to Tenor Tech, where I solve the problems you didn't even know you had.
You begin by preparing what the model will learn, data and tools. First, gather diverse, labeled images so your model generalizes, prioritize edge cases. Once you have raw data, annotate with a single schema like COCO or YOLO to avoid mapping errors. Simultaneously create an isolated environment, Conda or Venv, with GPU drivers and a deep learning framework. This prevents version conflicts and gets you training ready quickly, so you can iterate instead of debugging setup problems. You now design and train the model. Choose an architecture aligned with constraints, MobileNet for latency-sensitive devices, or ResNet/Detectron for top accuracy. Then apply transfer learning and augmentation to reduce data needs and improve robustness. Use mixed precision and batch size tuning to optimize GPU throughput. Make sure to set a consistent train/validation split, log metrics and checkpoints, and fix random seeds. This lets you compare runs and understand why one change improves performance versus another. Iterate. You finish by exporting and deploying the model. Convert to an efficient runtime like ONCS or TensorRT and consider 8-bit quantization to lower latency and memory. Once exported, wrap the model in a robust service with batching, warm-up, and health checks so inference stays stable under load. After deployment, monitor accuracy and input distribution for drift and latency for regressions. If results degrade, roll back to the last stable checkpoint and retrain with new labeled data. This rollback tip saves production time.
Thanks for watching. Subscribe to keep your life in tune.